In this video, I'm going to teach you how to find out what is the major product for the given series of reactions of one butane molecule. Once you find out what is the major product, you have to identify the correct structure from the given options, because in option A and B, the three-dimensional structures of the products given. In option C, there is a Fisher projection, and in option D, it's a Newman projection. So let's get started. When one butane, which is a terminal alkyne, is treated with soda amide, that is NaNH2, the reaction is between an acid and a base. So why one butane is acid? Because the carbon here is sp hybridized. When it is sp hybridized, it is electronegative. Therefore, the hydrogen will become electropositive. A base which is strong like soda amide will abstract the proton here and it will form a carbanion. And this is nothing but the sodium salt of the 1-butane molecule. Now, this is going to react with ethyl iodide. So, ethyl iodide, iodine is somewhat electronegative. Because of that, the carbon will become electropositive. Therefore, the attack of this carbanion, right? So, it happens on this electrophilic carbon. So, this is nothing but nucleophilic substitution reaction. And then what product can we expect here? So, the triple bond will remain as it is, attached to ethyl, and again it is attached to ethyl here also. It's nothing but 3-hexane molecule. So this 3-hexane molecule is going to react with sodium in liquid ammonia. The moment you see this reaction condition, you should know that it is a partial reduction of triple bond to double bond, and it's also very specific to the stereochemistry of the product. So we always get a trans alkene. And what trans alkene are we going to get here? Trans 3-hexene molecule like this. Now, let's do the last reaction, that is treating it with the bromine in presence of a solvent like carbon tetrachloride. So we are going to get a dihalo compound like this, a dibromo compound. But when you look at the options, all of them are dibromo, right? And they are vicinal dibromo. That means they are on the adjacent carbon. Then how to predict what will be the correct structure of the product? Very simple. You just identify the alkane, which is trans. This is a trans molecule. And then the addition of bromine is always the anti-addition. What does that mean? So when you take an alkane like this, right? When it is treated with bromine, alkane, which is electron rich, will attack the bromine, right? And then it's going to form a bromonium ion like this. These two carbons and this bromine, right? All these three are in the same plane. Now, what bromine does is the bromide ion, right? So this bromide ion attacks either from above the plane or from below the plane, right? So if this attack from above the plane, this bromine goes below the plane. So that is the stereochemistry. That means what? So you have to be very specific with respect to the position of the bromine, and the ethyl will be as it is here, and the hydrogen also like this. And also remember, this molecule will have plane of symmetry in it. Therefore, we call this as a mesomer. A molecule when these two carbons, right? So these two carbons attached to the same substrates like hydrogen ethyl bromine, then if it is having plane of symmetry, a plane which can divide the molecule into two equal halves, right? So then we are going to call this as mesomer. So remember, the molecule is trans, the addition is anti. In that case, the product will be mesomer. You have to remember the addition and the type of the molecule. Say, for example, if the molecule is cis, right? If the addition is anti, you are going to get the racemic mixture. If the molecule is cis and if the addition is syn, then we are going to get the mesomer. Like that same way, trans and syn will also give the racemic mixture. So this you have to memorize to know the stereochemistry of the products. So getting back to the options. Look at this. This bromine and this bromine, both of them are above the plane. So not correct. Now look at this. The bromine is above and below. This is absolutely correct. Therefore, the right option is B. But let's verify for C. The bromines are opposite. So there is no plane of symmetry here. Therefore, this cannot be the answer. This is not a mesomer. Now, when we have a Newman projection, so how to convert this to the Fisher projection to know whether it is mesomer or not? It's very easy. What you do is you fix the position of the groups on the front carbon. This is front carbon. So you fix the position of all the groups like ethyl, bromine, and the hydrogen. And then you take this behind this ethyl. That means you rotate the carbon by 180 degrees. So this goes behind this. And if it is going 180 degree, obviously the bromine will go behind the hydrogen and this hydrogen will go behind the bromine. So you see only these two are on the same plane, but hydrogen bromine are not on the same plane. Therefore, when you convert this to the Fisher projection, it looks somewhat like this. That means there is no plane of symmetry. Therefore, this is also not correct. So which will be the correct product with the right stereochemistry? It is as shown in option B. I hope I made it clear, and if you still have any questions on this, you can drop your questions in the comment section. Thank you. Until next time.